Alright, today we're going to be going over conditional probability. So what conditional probability means is if you have a probability of an event A, given that an event such as B has already occurred. So an example of conditional probability would be, let's say you had a kid and he was a boy, but then you had a second kid but it was a girl. Conditional probability would ask, what is the probability of it being a girl given that you already had one boy? And the formula for this is the probability of A given B, given being this line in the middle. And what it is this will be the probability of A and B divided by just the probability of B. So on this example over here, we have 52 cards and we want to find the probability of getting an ace given that we already drew a spade. So we're going to set this up just like we are formula. We have our ace being our A given that we already drew a spade. So now this will become our probability of ace and the spade divided by the probability of just the spade, which means at the top we'll have ace and spade, which there's only one of those in our deck of cards because we have 4 aces, 1 heart, 1 diamond, 1 spade, and 1 club. So 1 over 52 divided by our probability of a spade, which is 13 over 52, which will give us 1 over 13, which means that our probability for our ace, given that we already drew a spade, is going to be 1 over 13. Alright, so we're going to do our first example, which gives us this chart of A, the A complement, and B and B complement. And it's asking us to find the probability of A and B, as well as the probability of A or B. Part B is finding the probability of B given A and the probability of A given B. And then C is asking if A and B are mutually exclusive. So for question A, we're going to start off with the probability of A and B, because that's an easy answer. All you have to do is look at your chart and look to find B, find A, and try to see where their lines overlap. And if you notice, A will pass through 0.34, and so does B. So our probability of B and A is 0.34. Now finding the probability of A or B is a little bit more tricky, but it's not that bad. All you have to do to find this probability is probability of A or B is going to be equal to whatever the probability of A is plus the probability of B minus the probability of A and B. So the first thing we need to do is we need to find our probability of A and our probability of B. So there's 2 ways that we can do this. We can do it looking at the chart, or we can do it without the chart. So first I'll do it without the chart, but then show it with the chart. So our probability of A will be equal to the probability of A and B plus the probability of A and B complement, because our B's will cancel out, leaving us with just the probability of A. And same thing with the probability of B. It'll just be the probability of B and A plus the probability of B and A complement, which, if you notice at the chart, all you really have to do is add our A column to get our total for our A, because that is adding our A and B and our A and B complement. And the same thing for B. You just add the B row because it's A and B and A and B complement. So this would give us 0.8 for the probability of B and 0.49 for the probability of A. So now we're able to answer our question of the probability of A or B, because this will be equal to 0.49 plus 0.8 minus 0.34, which will give us a final answer of 0.95. Now we're going to go over part B, which is the finding the probability of B given A and the probability of A given B. So we'll start off with the probability of B given A. And since we did all this prep work for question A, this part will be very easy because it's just plugging our numbers into the formula. because this will be the probability of B and A divided by the probability of A, which we already have from before as 0.34 divided by our probability of A, which is 0.49, which gives us 0.69. And then we'll find our probability of A given B, which is the same thing as same top of 0.34, but our bottom, instead of the probability of A, will be our probability of B, which is 0.8, which will give us 0.43. And finally, I'll put in the bottom corner, is asking if A and B are mutually exclusive. So what mutually exclusive means is that A and B have no part of each other. So if you had a Venn diagram, a normal Venn diagram would look something like this, and they have a little and in the middle, meaning that they're not mutually exclusive because they're together. But a mutually exclusive graph would look something like this, where our A and our B have nothing to do with each other. They're on opposite sides of our space. But if you remember from part A, we do have an A and B, meaning that our A and B cannot be mutually exclusive because our probability of A and B does not equal 0. Therefore, no, they're not mutually exclusive. Alright, now we're going to go over Bayes' theorem, which is just more ways to write our conditional probability. So we have our probability of A given B, which will be equal to the probability of A and B divided by the probability of B. But this could also now be equal to the probability of B given A multiplied by the probability of A, all divided by the probability of B, which could also be equal to the probability of B given A multiplied by the probability of A divided by the probability of B given A multiplied by the probability of A plus the probability of A given A complement multiplied by the probability of A complement, which is another way that we could get our probability of B. Because if you notice, the only thing that changes between our second formula here and our third formula is our denominator. But that's because they actually equal each other. So our probability of B could be the probability B given A multiplied by A plus the probability of B given A complement multiplied by A complement, which will all give us our probability of B. Alright, now we're going to do a question using one of the formulas from our Bayes' theorem for an adoption center question, which states that there is a 45% probability that anybody that goes will get a cat, and a 55% probability that it will be a dog, and that probability of a male given that they chose a dog is 0.65, and the probability that it's a male given that they chose a cat 0.4. So now what we want to do is try to find our probability of just a male. So if we have our male as A, to use our normal formula to find our A, we would need to have a B and a B complement. But we don't have a B or a B complement in this equation. So instead, what we're going to do is we're going to use the denominator of our third Bayes' theorem, which would state that the probability of a male given that it's a dog multiplied by the probability of a dog plus the probability of that it's a male given that it's a cat multiplied by the probability of cat should give us the probability that it's a male. So if we put all our numbers in that we know, we could get male given dog, which is 0.65, multiplied by the probability of dog, which is 0.55, and this is going to be added by male and cat, which is 0.4, and that's going to be multiplied by just the probability of cat, which is 0.45, which will total us getting a probability that it's a male of 0.5375. Alright, now we have question 3, which is about late night shows. So our A1 is the event that a randomly selected person watches The Tonight Show with Chris Pratt. And A2 is the event that a randomly selected person watches the late night show with Stephen Curry. And then, we have the probability of A1 and not A2, which means that they're watching just Chris Pratt and not Stephen Curry, is 0.1. We have the probability that they don't watch Chris Pratt and they do watch Stephen Curry, which is 0.5. It's the probability that they watch both of them is 0.3, and then the probability that they watch none of them is 0.4. So our question A is going to be, if we know that a person watches Chris Pratt, what's the probability that they also watch Stephen Curry? So we're looking for the probability of A2, but we already know that they watch Chris Pratt, which is given A1, which means we're going to be looking for our conditional probability of A2 given A1, which is the probability of A2 and A1 divided by just A1, which we're going to use one of our formulas from before, since we have all of these above to work with. So we already know the probability of A2 and A1, so we can get that out of the way, because that's just going to be 0.3. But now we have to divide it by just A1, which will be our A1 and our complement of A2 plus A1 and just our regular A2, which will give us 0.3 over 0.3 plus 0.1, which will give us 0.3 over 0.4 over 0.4, which will give us 3 out of 4, or 0.75 if you want in decimals. Question B is, if we know someone already watches Stephen Curry, what's the probability that they also watch Chris Pratt? So we're going to have the probability of this time is going to be A1 given A2, which again will be the same formula with just A2 at the bottom. So we can already put 0.3 at the top, except this time our denominator is going to be A2 and A1 complement plus A2 and A1 regular, which is going to be 0.3 divided by 0.3 plus 0.5, which gives us 0.3 divided by 0.8, which gives us 3 over 8. And now finally we have our question C, which is going to be, what's the probability that a randomly selected person watches only Stephen Curry but not Chris Pratt? Which means we're looking for the probability of only A2 and not A1, which is the complement of A1, which you can see is already in the question at 0.5. Alright, now the final topic we're going to be going over today is independent events. Independent events is where the probability of the first event that occurs does not depend on the second event that occurs. So an example of this is, let's say you flip a coin. So the probability of getting heads is going to be 1/2. But if you flip a second coin, the probability of getting heads is still going to be equal to 1/2. Just because you get a heads in the first event does not determine what you get in the second event, which means that they would be independent events. So there's a couple ways to check for independent events. The one way is if the probability of your first event and your second event is equal to the probability of your first or second event multiplied by the probability of your first event, then they will be independent. Or if you have the probability of your second event given your first event and it equals to the probability of your second event, then they will be both independent. And this second formula also works with the probability of A given B is equal to the probability of A. Alright, so we have our first question again, where it's our chart of A complement, B, and B complement. But now we're going to try to see if these two events are independent or dependent. So what we're going to do is since we have our probability of B, A, and our A and B, we're going to put them into the formula to see if they're independent, like the coin flips, or if they're dependent on each other, meaning that this equation would fail. So we're going to have the probability of A and B equaling to the probability of B multiplied by the probability of A. And the probability of B and A is 0.34. And now we can test it because we're going to have the probability of B, which is 0.8, and we're going to multiply that by 0.49. And this will give us 0.34, but instead of 0.34, when we multiply them together, we get 0.39, which means that our events A and B are not independent because our equation of the probability of A and B does not equal the probability of B multiplied by the probability of A.